the whole point of this is to sort of open your eyes to another world of development. So at the moment, like a lot of the stuff that we do is just on the phone, right? And it's always good to develop skills that branch out from that, just in case Apple decide to do something that destroys apps altogether. And when we're living in a world where things are getting more and more connected, so like you've got your smart TV, you've got, I mean, people have, you know, coffee makers that are smart, they have fridges and that sort of stuff. And so it's good to be able to write an app that can interact with these devices. But why not create a device that can do that for you too? Like, how cool would it be if you had an app that could measure how wet the soil is outside in your garden, right? You make an app that does that just for you. Some of the things I've got here in front of me, so we all know we're not going to be dealing with this. So Raspberry Pis, that's not something we're going to be messing around with too much. So the main kind of boards we're looking at are, sorry, I've got so many of these laying around the place. So the one that I have most familiarity with is probably the ESP32, and that one has been around for a little while now, and it comes with Bluetooth and Wi-Fi built in. And so this top section you can see here, it's kind of like, I'll move my face behind it so it doesn't focus on it. See that top board? It kind of like, there's like a little board that's sitting on top of this bigger one, and it's got this shield on it, and it kind of ends along the bottom there. So that's it there. That's the entire ESP32. There's a little chip inside there. I'll show you what that looks like in a minute. And I've got another one here. See how they look very similar? Alright, they're different. They look quite similar. And you can see that on this Pico, we've got a similar kind of, like here's the older one. And the other one's got this section up here with the shield and stuff. So these are, so this one is wireless. And so are these little boards on there. So you can get these separate that aren't on this main board. But you have to do you have to do all the other electronics work yourself, like solder on or something or whatever. But these are great for prototyping, right? And what you want to do is try and purchase one of these. They're really, really cheap. I think you can get for like $2, right? AliExpress or something. You just get a whole bunch of them because you may blow some up. So this one here, my favorite one I've been using for development is probably the Fire Beetle. You can get other ones that are a bit smaller, but I like this one because it has this, see these two at the top? That's so you can hook up a battery. I think, yeah, so this will actually hook up a battery and it will charge it. On the front there used to be a socket there that I've removed since, but you could plug a battery directly into it and it will charge it. It will, monitor its level. Or, you know what I mean? It has a full like regulator and stuff like that on it, which makes it super easy. You can just, hook up a battery to this thing and then have it run for days, depending on what you're running on it. If you have a script on there that's just like capturing temperature or something like that every hour, you can have like mini weather station built with one of these, and then you can build an app that talks directly to it or just pulls data from it. It's pretty cool. Another thing that people use these for are like servers. You could run a website off one of these if you wanted. It wouldn't be very great, but you could do that. I think most people who are using these kind of go with that direction because, like if you're mainly working on like a PC or something, you just want to open up a web browser and then view the information that these boards are putting out for you, right? But instead we want to build an app. That's the whole point of this process. This one here you can see is another Fire Beetle. All right, same as the one I showed you before. But on the back, I have stuck a sensor and a battery. Yeah? And the battery is like soldered on and I've hot glued it down. So hot glue is really good to have when you're working with electronics. You just hot glue everything. Mainly because it's very easy to remove. And yeah, you can see here the poor solder job there. So there we go. So this sensor is 6 degrees of motion, so it will detect, like rotation, forward and back, up and down, rotating this way. It's got gyroscope and an accelerometer on it. And that's what this board looks like. You can buy these just off the shelf. There's a lot of companies that make these kinds of things, like it's just a chip. It's like a breakout board, right? It's just the chip on there, the sensor, and then they have, you know, inputs, outputs type of thing. Like, so you got your power and stuff, you can go into these, and then the readings that come off it. Let's take a look at the ESP32 in particular. So this is covered with a shield, right? So here's one that I ripped the antenna off on the left. And the one on the right is like one that's complete, but it's missing, you can see that's missing the chip. You can see that silver pad just under the antenna. All right, so I was using these to program my own ESP32 chips. And so like I'd solder them on, program them, remove them, and then put them onto a custom board. Now, that's not the ideal way to do it. You should be able to program it from your custom board, but I didn't put, you know, breakout pins or anything like that on it. I try to make it as small as possible. So the only way I could get this working was to program them onto another board, then remove it. And I had to use these ones because all these others have the shield on top covering it, right? So inside these, you can see that's the chip there. That's the ESP32 right there. Yeah. And so there is some supporting circuitry around it. We've got a couple of switches. The switches are used to like put it in a programming state. So you would hold them both together, then release one, and there's like a combo that you can do that over USB, the computer will pick that up and go, oh, okay, this is in programming state, means I can push information to it. The custom boards that I have don't have that feature as well. I don't have a thing where I can put it into programming mode. And that's an issue. That's why I've had to manually go back and forth with switching chips around. I'll show you what they look like. You got to keep them in like a very dry box, because if they get moisture in them and you heat them up, they can crack. So it depends on the, like, you know, resistors and stuff can just be out in the air and that they're pretty well sealed, but some chips do take on moisture. So this is the chip. See if we can get it to focus on this and not a face. So that's an ESP32. Yeah, tiny. Something else I've got here, which I have been putting on the custom boards, is IMU, which is inertial measurement unit, which is an accelerometer gyroscope. You can get IMUs that have different, you know, you can get them that adjust the gyroscope, you can get them that adjust accelerometers. You can get them that have a magnometer in them, so you can measure like where north and south is, basically. So that's it there, tiny. I think that might be the last one I've got. No, I've got another one. In here, so I 3D printed these little containers. They work okay. If you can see that, there's a few more ESP32s in there too. If you buy them in bulk like this, they're really cheap. And you have to, if you're doing hardware stuff, you gotta buy them in bulk because you break them all the time. And it's sometimes really difficult to know whether they're actually broken, because it's not that you can just put them in a testing jig or whatever. You can probably get something like that, but man, that's a full lab that I don't have access to. Another board that I got, which I haven't had a chance to use yet, because as soon as I bought it, I kind of stopped doing that work and focusing on, you know, iOS more. But we've got this is pretty cool. This was really like affordable. I think it was like $10 or something. And it's like a board where you can plug in multiple modules without having to do this whole like solder on. So this is great for prototyping, right? So you put all your stuff on here, you test it out, and then once it works, then you can go and design the circuitry if you want to make it smaller, right? And then buy all the individual parts and put them on the board. So in this case, this thing is for, this is for a Pico, it's called a Pico Quad Expander. So it's got four other modules you can put on here on top of the Pico. So this would go in the middle. you would solder some pins on this, slot it into here. Up here you've got the USB, so you don't have to use this one anymore. And then you would get something like this board. Now this board has, apparently this is a 10 DOF IMU. So this, I don't know what the extra one is, but this has an accelerometer, a magnometer thing, and a gyroscope in it. I'm not sure what the last one is, but it's got 10. And that will just slide on here. It's pretty tight fit, so I'm not going to do it. It slides on there. You line them all up correctly, and then you've got all this text and stuff on the board, so you know where your inputs and outputs are. And then you can just get like jumper leads and stuff, and then add them to other things. Like this board, for example, won't fit on there, so you'd have to rig something up for that. I know it all seems kind of complicated, but I found it to be remarkably simple. Like looking at schematics for these boards, what you want to do is, like, when you're starting out, you want to go for like the most simplest design ones, like these ones, right? So all this has on it is the chip itself, a couple of buttons, it's got an LED, it's got like a voltage regulator, and that's kind of it. Right, you'll see like there's capacitors. You can see, there's a clock up there too. Which side is it? You can see the clock, these little metal, right at the tip of my finger there. See that little, all clocks pretty much look like that. So let's see if we can find another one. And that's what's underneath this shield. There's a clock under there too. I'll tell you about that in a second. Oh yeah, on the Pico you can see it. See that there? That's the clock for the CPU thing. This one has it as well underneath there, so that's another important part to get this working. But yeah, like I said, other than that, all you've got on the board is, the main CPU, a couple of LEDs, which you don't have to have, some switches, which you don't have to have, a clock, and then some, capacitors and resistors for balancing, the current out. Look, I'm not a professional at this. I learned on my own how to do it, so some of the terms in that are probably incorrect. And I'm trying to use simpler terms as well for other people like me who may not be all that versed up on hardware. So, what are you planning on making? Then what type of app will you be developing? Yeah, well, I'm just going to go with whatever I've got here. So I've got some of these. I've got an IMU. So this will just measure motion. I just want to start with something really simple, right? That I can demo and give you enough information to go out and just experiment and build your own. But whatever you do for this, the measurement, sensor, motion detection, should apply to anything, any other sensors you want to put onto a board. You can buy kits for this too. Like with $40 off Amazon or something, you can get like a development board that has like 50 sensors that come with it, depending where you are in the world, I guess. And then you can experiment with all these. A lot of the stuff. So there is. You can do this with Raspberry Pis as well. You can go and get a kit, and then they can give you like it's backwards, a good book, and it gives you like, the simple programming languages like Scratch. I used that for about, I don't know, half a day, and then I just went straight into a regular IDE to make this work. There's a number of different IDEs you can use to program these hardware devices, and they're important because they have the capability in them to talk to these things. So once you put them into the mode for writing the software onto them, the firmware, the app, the IDE you're using can detect when it's in that mode, and then it can push like your code to the device. So you can't really get away with like just using a text editor, right? You're gonna have to use some other software to implant this stuff. It's just much like Xcode, where you can't really install an app to your device unless it's you can't build and debug and all that unless it's through Xcode. You can do anything in software and hardware. Just how much time do you have, right? This stuff has come a long way, right? There's so much documentation out there on how to do this that it's just like playing with Lego. Honestly, everything is mostly matched to each other, all the components. So it's like you can go, okay, I want this, this CPU, I want to put it with this sensor, and then usually it'll just work. But you do have to read the documentation. So already you can kind of see what's going on, right? Like what this is. This is the schematic for the Fire Beetle, right? Like I said, I really like this one because it's got the battery charger and stuff built on this board. So anytime the battery goes flat, you just plug it in, charge it up, and then you're good to go. But this is the Fire Beetle, and on here you can already see. Can we zoom in? Like you can kind of recognize what this is, right? This is the USB for it. Yeah, and you've got these four lanes here. You got some voltage in, you've got data, and then you've got like negative or ground, right? On the boards, they will tell you what resistors you need to use. So like in the documentation, it will say, hey, you should put these here when you're connecting it to USB. This here is, I believe this is the USB chip. Yeah, so we got the TXD, RXD. So this is, yeah. This is the USB chip. And so this allows you to pass data through the chip, and then this passes it back, passes it on to the CPU, we'll call the ESP32. And then you can also use this for power. You can there's also a battery down here. You can see this battery section here. That's used for power as well. If you follow these around, you just jump into here and you follow these lines around. You can see this is the regulator, right? So most batteries that you get are 3.7 volts. You can get them all different sizes, but most of them are 3.7, like this size. I think this is 400 milliamp hours, maybe. So they're 3.7, so you need to drop that down because a lot of these chips run on 3.3 volts. Some of them run much lower than that. Some of them run on 5 volts. That's why you got to read the spec sheets for them. So this is, I believe the ESP32 is 3.3, so you've got to drop your battery levels down to 3.3. And that's what this voltage regulator does. 5 volt. So the USB is 5 volts, right? So you'll need a regulator for that. So you need to drop 5 volts down to 3.3, and you also need to drop 3.7 volts down to 3.3. And you just get this like one chip that does that all for you. So you're just like, don't have to worry about that. Each of your sensors, so the CPUs or ESP32 or the Pico, whatever, the chip that you're using, it will have certain communication capabilities, right? Some of them can communicate across all different formats. So basically, it's just like the way the data is being transferred between the chip itself and maybe a sensor or something, right? Some sensors can only be used with one of those, so you need to make sure that whichever sensor you're getting can talk with the CPU that you're using, right? So most CPUs can do all of them. Pico Dev Motion Sensor is an MPU 6050. This is pretty common. I think it's getting on now, MPU 6050. I think the most used ones in the industry now are like the Bosch IMUs, and they were out of stock for like, I don't know, 2 years or something. I think they're just coming back now. But they've got like an onboard computer in them as well, so you can actually run, you can offload some of the work from your CPU to the actual motion sensor, which is kind of cool. These ones just like spit out values, just raw values, right? So look, that thing in the middle. And you can see on the side here, we've got, so going back to the communication protocols between the two, we've got, on this board, we've got ground, we've got 3.3. So this runs off 3.3 as well. So that's great, right? Which means the power can come directly from the main, from the ESP32 if you want it to, or it can come from the battery or whatever. Basically you can pass your 3.3 volts into the chip, which is this here, and then you can bring it out and then go into your sensors, or you can have it come from the regulator into your sensor. You can, it's up to you. But in our case, we don't really have much control over that because we're working with dev boards and that's already set up. So pretty much all that's going to happen is when you're using one of these dev boards, you will be putting power in either through the battery or the USB. It's the easiest way. You can put power in, if you have a desk power thing, you can put it through one of these pins as well. They generally take 5 volts in. They won't take 3.3, but some of them do. But because the 3.3 on this is usually like going to another sensor. So you can just go from a pin on this to a pin on here, right? You hook them up that way. So what we got here is we've got SDA, SCL, and those are the ones, that's what I use. And let's see if we haven't got anything. We've got SCL here. Yeah, so SCL, SDA. So these little thin wires that I've stuck on there. And in most cases, that's all you need to do when you're doing prototyping, right? You get these larger boards, they're great for prototyping. They've got all these inputs and outputs, all these little holes on it, and you can hook anything up to them. So that's how it communicates. The SCL and SDA is how it communicates. We won't go into too much of that today, maybe another video when we're actually programming it. But basically that's all you really need to do, hook these things up. I think I've got, yeah, you can see over here too, I've got ground hooked up, and that goes directly to the ground. So everything's labeled. Like I said, it's like Lego, right? You just hook these all up together, and then most of the work is done in the software. That's probably the hardest part. I find that I did find that iOS development and writing code is much more difficult than doing hardware. I think hardware can be more time consuming because when you find an issue, it's really difficult to track down if you don't have the proper equipment to do so. Like it's hard to tell if you've got like a faulty connection, like you've badly soldered something, or the chip's blown up, right? Or, you know, the battery's dead, you can test that, but you've got like, I find that you just have so much test equipment and that's all for different things, and you kind of, it's frustrating sometimes. The oscilloscope is great to check to make sure, like your clock could be broken. Like any little piece of hardware that's broken on it could mess up the whole thing. So you got to test that and make sure that's outputting the correct frequency. Okay, so talking about signals and clocks and stuff like that, I think I'll leave that for another time. You can't see the clock on this schematic because it's inside this. Oh, hang on, you can't see it. It's inside this chip. So when it's saying ESP32, it's talking about this entire module on top on this schematic. It doesn't go into details of what's inside this board. And I think that'd be important to have a look at. So let's do that. What do we got? This down here, I think is the battery charger. No, this is the charger. This is the regulator. Yeah, sorry, I got them mixed up. That's okay. Well, it's fine. It's fine. Okay, so yeah, you can see there's only, on the entire board, there's really only 4 items, right? And if this was like another dev board, which doesn't have the battery charge circuitry, you'd only have these 3 items, right? And mine don't even have USB capabilities, the ones that I built myself. And so all that I have on there are just these 2. I have 3 because I do have a battery charger built in. All right, anyway, let's move on. We've got a couple other things to get through real quick. So let me take a look at pulling up what is inside this module, all right? So we can take a look at that real quick. These are really cool, these M5 stamp things. I've got 2 of them. And that's these, they're tiny, tiny, tiny. Excellent devices. Let's take a look, see if I can find the spec sheet for this thing. They have gotten expensive. Wow. More expensive than 5-bit. Oh, you get 5 in a pack. That's probably okay. So check this out. So this isn't too bad. So you get 5 of these boards in a little strip. And that's great if you blow one up, but $30, that's I don't know whether that's US or AU. What we got? But yeah, sites like this will sell you all kinds of fun stuff. You can get lost on there. And anytime you're building custom boards, it's great to just borrow a schematic from someone else to start with. Copy, grab all the parts, throw them on board. You also need to make sure that those parts are available. So you look up sites like Mouser or DigiKey and then just see if there's, the part numbers, look at the part numbers, and if they're available, get them. You can also look for alternatives, like sometimes the parts are too expensive to buy like 5 at a time. Maybe you want to get something a little bit cheaper. All right, check this out. So this is everything we need to know about it. It's got some specs here. So the ESP32 has got 32-bit RISC-V single-core processor. Not the most powerful, but it will be okay for just grabbing sensor data and sending it across Bluetooth. There are some limitations to Bluetooth as well. There's only so much information you can send at a time, and they're sending like packets, and it's only so quick you can send that information. And there's huge limitations with Bluetooth, and this is why like Bluetooth headphones get all weird when you try and have the microphone on at the same time as audio coming in. It can't do both at the same time very well, so it has to like reduce the quality of the music. So I don't know if you've ever noticed that when you try getting on a call and stuff with Bluetooth headphones, it's not great. Wi-Fi is obviously, everyone knows that, it's much better. You can gigabits or whatever, if I think. But yeah, Bluetooth is rather limited. So if you need like real-time sending of motion data, like you want to capture this in real time, moving it around stuff, I think the most I've been able to get out of is like 100 updates a second, which isn't going to give you like precise, measurements. Another idea is that you could batch them together. So there is a limit to how many pulses you can send out across Bluetooth per second. So you could like group the information together and then send it, but then it wouldn't be quite real time. So let's scroll down. So we've got all the pinouts on this thing, which is really, really great. You can see that it's just got the USB-C for powering. It doesn't have any battery or anything like that. It doesn't have battery charging circuitry. But you can see this is the chip here. There's the clock. And then you've got like capacitors and stuff to smooth out power. There's the two switches where in certain combo you can program it. And then there's this little LED. And when you plug it in, I think you can program the LED as well to change. I think this is an RGB one. You can change colors. I think, yeah. When you first get this board, it's got some software programmed into it already. So when you plug it in, it'll cycle through some different colors, and then you can upload your own. When you have power going into your chip, and it's like say 3.3 volts, it's not always going to be a steady 3.3 volts. Anytime the chip does work, it's pulling power. Like if you want it to do some work all of a sudden, it's going to put a load on that regulator or the battery or the USB, right? And the power like drops just a little bit anytime it sort of does that, and then it has to sort of come back up again. You want to try and smooth those spikes out, and that's what these capacitors kind of do. So what a capacitor does is they're kind of like mini batteries, right? But they discharge really quickly. And so when things are smooth and fine, they charge up, and then when there's a load, they can output their power to make sure that that 3.3 volts doesn't drop too much when the chip starts doing its work. Yeah, so this is the bank of capacitors I was talking about. And you can see they go from 3.3 volts down to the ground. And that, like I said, that helps smooth out the voltage changes when the chip's going like crazy, like trying to, it does this bit of work that's really intense, and then it goes back to idle position, and then it does a bit more intense work. If you're like rotating a device and it's trying to crunch the numbers of the motion sensors and stuff like that, it's going to be drawing more power than if it was idle, right? And so that's why you need these to balance out those spikes. And a capacitor, I think, look, there's so many other videos on YouTube that explain these things much better, but I think if you want to do some more research in this first before we do the next one, so look up some of these more passive components. That's what they're called. So active ones are like your computer chips, basically. Passive ones are like resistors and capacitors. Look up, they can better explain what a capacitor is, what a resistor is. But I think if anyone's taken like some high school classes on, because I remember doing some circuitry in high school. I don't know if everyone got a chance to do that. You should sort of you should already know what they are. Like resistors will put resistance in it can lower voltages and things like that, right? You've got capacitors. Capacitors are like an open circuit, but there's like pads that are really, really close together. And so it's kind of like, you know when you build up like static electricity, right? And then you get like really close to an object, and then a little spark kind of can jump across and that discharges. So you're like a battery when you charge yourself up with your socks on and you touch like a doorknob and you're releasing that charge. That's kind of like what the capacitor is doing, right? Yeah, so one side we get it fully charged up, and then once it gets too far for the, you know, the gap, it bypasses the gap eventually and jumps across. But that's it for this board and probably this video, because I think the main thing is I wanted to get like an intro for this stuff done. Just to recap, we're not working with Raspberry Pi, which is a full computer. It's an actual computer. We're working with microcontrollers. And that's what this series of videos is going to be about. Just the really, really simple chips that are designed to do basically one thing, really. Listen for input, process it, put it out. I guess that's what all these things do. But this has, you know, USB things, Wi-Fi, it's got graphics cards and stuff on it. We don't need any of that stuff. We're only caring about like just processing raw data. There is an ESP32 chip that has a camera on board though. I'll show you that real quick because you might be interested in that. Maybe you can create like, I think it is only like this big too, with a little camera. So what you could do is like hook up a battery, stick it somewhere, and then do like a time lapse. This actually has an SD card on it. So if you wanted, you could use this to record, you know, your video, or you can do time lapse photography on this, and then you just take the SD card out, put it in your computer, and you've got yourself a nice time lapse video. Maybe you set it up for 12 months or something, a whole year. You know, take it one photo every day. Be kind of cool. This has, yeah, the camera comes with it too. I was thinking, oh, maybe it doesn't, because I didn't see it there. So this is the ribbon cable here where the camera plugs into, and that's it. That's it. It's so tiny. And yeah, like I said, it's got a little SD card and stuff on there. It must be all pre-programmed. It still has your inputs and outputs, so you could maybe if you want to take photos at night, you could plug in a little infrared LED, because the camera should be able to pick that up. You can plug in a motion sensor, so anytime motion's detected, it will snap a photo. And then, you know, you're seeing it, if it's cold outside or something like that, you don't want to go out there to see what's going on. You just open up your phone, you can send a notification to your phone, right? Because these things can run a web server on them, you could set up a push notification server so that when something happens, it sends it off to Apple, push notification, if it's connected to your Wi-Fi. And then you'll get a notification on your app, open up your app, and then hey, maybe you see your picture on there. That'd be kind of cool. Maybe that's a project we could do in the future. Yeah, I think for the most part, that's it. Next time we'll look at the IDEs for this. We'll write some code. So we're still going to stick with the hardware. We're not doing the iOS portion yet. We're going to do the hardware. We're going to make a light flash on and off, and then we're going to write code so that it only flashes on and off when it receives a signal across Bluetooth. And we're going to talk about all the Bluetooth connectivity and how that works too. It's simple. Anyway, thanks for joining. Thanks for watching. Got any questions? Yes, leave them in the comments. See ya.